On September 18th, 2025, the world was shaken by a pair of events so improbable they seemed torn from the pages of myth. Within the span of 72 hours, the Kamchatka Peninsula in Russia convulsed under the force of an earthquake measuring 7.8 in magnitude, the newest shock in a relentless chain that had begun months earlier in July. Yet just 3 days before the ground split apart, the heavens themselves had stirred. A geomagnetic storm of category G3 lashed against our planet. Born from a sun rousing after 11 long years of quiet slumber. Was this merely coincidence? Perhaps. And yet, there is another actor moving silently across the stage of the cosmos. 3I Atlas, the interstellar wanderer racing toward our sun, carries with it a luminous shroud of plasma already half the size of the sun itself, swelling greater with every passing day. Whether this heralds danger or revelation, one truth is certain. Humanity now bears witness to a phenomenon that has no precedent in the chronicles of our history. Stay with me tonight, as we seek to untangle whether these converging wonders are accidents of chance, or threads woven together in ways science has scarcely dared to imagine. Part 1. The sun is waking up. On September 18th, 2025, the earth trembled with ferocity. A magnitude 7.8 earthquake tore through the waters off Russia's Kamchatka Peninsula, sending shockwaves across the restless arc of the Pacific Ring of Fire. Yet this was not the only assault on our planet that week. Just 3 days earlier, Earth had been battered by a very different force, a category G3 geomagnetic storm. Among the strongest bursts of space weather that year, sweeping invisibly through our magnetosphere like a vast, silent tide. 2 upheavals. One weekend, and nestled between them a question any sober scientist would hesitate to ignore. What are the odds? Our sun is awakening. After a long stretch of relative calm, solar cycle 25 is nearing its peak, and the statistics tell a tale both captivating and uneasy. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center has been charting an increase in activity, more coronal holes, faster solar wind streams, and magnetic turbulence bright enough to paint auroras over skies as far south as Colorado. But the storm of September 14th to 15th held an unusual origin. It was not born of a solar flare or a massive ejection of plasma, but of something quieter, more enduring. A coronal hole, high-speed stream. Imagine the sun's magnetic field lines opening like the petals of a colossal flower, forming corridors through which torrents of charged particles surge toward Earth at speeds exceeding 600 kilometers per second. And the earthquake that followed was no common aftershock. This 7.8 rupture struck in the very same region that only 7 weeks earlier had been devastated by an even greater catastrophe. An 8.8 magnitude quake. One of the mightiest tremors ever recorded by instruments. That July 29th convulsion had stirred tsunami warnings across the Pacific Basin, activating sensors from Hawaii to Chile in fear of waves capable of redrawing shorelines. Any seismologist would rightly point out that earthquakes are born of tectonic forces, the slow, relentless waltz of continents grinding together over billions of years. They are correct. Yet might there be another layer to the story? Into this unfolding drama enters a third character, 3I Atlas. Officially catalogued as C2025N1. This is no ordinary comet. It is the third verified interstellar visitor to our solar system, a wanderer from the abyss between stars, now racing toward its moment of closest approach to the Sun. On October 30th, 2025, it will reach perihelion at a distance of about 1.4 astronomical units. Before doomsday visions arise, clarity is needed. 3I Atlas poses no threat to Earth. Its nearest pass to our planet will be 1.8 astronomical units away, roughly 168 million kilometers. A gulf greater than the very span between Earth and the Sun. What it offers is not menace, but an unparalleled chance to learn. Here lies its wonder. The Hubble Space Telescope has captured something extraordinary. This interstellar voyager is already alive with activity, building a vast halo of gas and dust at a distance where most comets still sleep. Its coma may reach 700,000 kilometers across, nearly half the girth of our own Sun. Picture it, an alien body forged in another stellar nursery, carrying chemistry from a distant system, swelling into a globe of activity large enough to engulf several Earths and still leave room to spare. And it does this while still millions of kilometers from the warming grasp of our star. But let us be clear, mainstream seismology recognizes no proven link between solar tempests and earthquakes. The United States Geological Survey, the foremost authority on seismic science, affirms that tectonic mechanics govern earthquakes, not the weather of space. As we venture into alternative hypotheses, we must treat them as conjecture, not fact. Even so, the timing gives pause. The September 14th storm was born from a recurring transequatorial coronal hole, a steadfast breach in the solar magnetic field that had hurled streams of high-speed particles toward Earth for days. This very formation, tagged CH1316 by solar scientists, continued to shape multiple disturbances across the month of September. High-speed streams of solar wind, born from coronal holes, behave very differently from the spectacular eruptions we usually imagine when we speak of space weather. Rather than striking like a single blow, they press against Earth with a steady force that can persist for days. During such episodes, the density of the solar wind can plunge to less than a single particle per cubic centimeter, even as the velocity surges to nearly twice the familiar baseline of 400 kilometers per second. For those curious enough to follow along, these conditions are not hidden mysteries. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center publishes continuous readings of the KP Index, a scale ranging from 0 to 9 that measures geomagnetic unrest. Anything above 4 begins to tug at our technologies, while readings of 6 or 7 can interrupt power grids and distort GPS navigation. On the ground, the United States Geological Survey maintains equally open records of seismic events. Every tremor greater than magnitude 2.5 is logged, analyzed, and released to the public within minutes. When headlines grow noisy, and they will, these are the beacons of truth to anchor yourself to. But let us turn our gaze back to the visitor from beyond. 3I Atlas does not cross this restless heliosphere alone. October of 2025 is set to be one of the busiest months for comet watchers in recent memory. Comet C 2025 R2 Swan is expected to sweep past Earth between October 19th and 21st, at a distance of just 0.26 astronomical units. near enough to grow a tail that binoculars can easily reveal. At the same time, C2025 A6 Lemon is flaring brighter with each passing night, with forecasts suggesting it could reach 4th magnitude before the month ends, luminous enough for the naked eye beneath darkened skies. Multiple wanderers, an awakened sun, and Earth rumbling with some of its strongest seismic releases in more than a decade. Coincidence? Perhaps. Yet as we move forward, we must acknowledge that a handful of researchers have offered mechanisms hinting at deeper connections, ways in which these phenomena may weave together into a pattern far stranger than our present science is willing to embrace. Here is what we can assert without doubt. The sun's magnetic field stretches outward far beyond its glowing surface, sculpting a vast heliosphere that enfolds all the planets and reaches deep into interstellar space. When objects, such as 3I Atlas, cross into this dominion, they become part of an immense electrical circuit that spans billions of cubic kilometers. Their comas, immense veils of plasma and dust, can interact with the solar wind, the magnetic fields threading between worlds, and the complex currents that flow across our cosmic neighborhood. The issue is not whether such interactions occur, they most certainly do. The issue is whether they carry enough strength to stir geological processes on a planet more than 150 million kilometers away. Could the delicate tension locked within fault lines be tipped toward rupture by subtle changes in the electromagnetic sea that encircles us all? As this investigation deepens, we will divide the evidence into 3 streams. First, the verified data, the space weather records, seismic logs, and astronomical observations that are beyond dispute. Second, the contested claims, the theories proposing links between solar unrest and earthquakes, theories that stir fierce debate among scientists. And third, the speculative frontier, the daring questions that stretch the limits of accepted knowledge. Our path begins with Kamchatka, a peninsula shaped by tectonic fury, one of Earth's most violent stages. Yet even here, amidst the clear mechanics of geology, the timing of events, their clustering, and their strange rhythms invite us to wonder for what might unfold when an interstellar traveler cloaked in a plasma shroud, half the size of the sun, drifts into a solar system already gripped by magnetic turmoil. That is the mystery we now face. Part 2, the Kamchatka Cluster, unprecedented seismic. Let me draw for you the scene of July 29th, 2025, at 14 hours, 55 minutes and 10 seconds. Coordinated Universal Time. The seafloor off Russia's Kamchatka Peninsula convulsed. In less than 3 minutes, a fault that had remained locked for decades suddenly gave way, releasing energy equal to 32 billion tons of TNT. The earthquake that erupted reached magnitude 8.8, a titanic convulsion so vast it shortened Earth's day by tiny fractions of a second. Almost immediately, tsunami alarms rang across the Pacific Basin. The Deep Ocean Assessment and Reporting of Tsunamis Network detected waves hurtling across the ocean at speeds near 800 kilometers per hour, while satellites from NASA's JASON series confirmed crests rising more than 3 meters even in deep water, surges bearing the power to erase coastal cities thousands of kilometers away. What makes this episode remarkable in seismic history is that it was not entirely unexpected. The Kamchatka Peninsula straddles one of the planet's most dangerous subduction zones, where the Pacific Plate relentlessly plunges beneath the Okhotsk Plate at nearly 8 centimeters each year. This slow-motion collision has been storing strain for centuries, priming conditions for what geologists call a megathrust earthquake. Here, the architecture is nearly perfect. The Pacific Plate dives beneath at a gentle angle, creating a vast fault plain capable of breaking for hundreds of kilometers at once. When such a boundary finally ruptures, the overriding plate snaps like a bent spring, heaving up immense volumes of seawater in an instant. What no one foresaw was the extraordinary clustering of giant tremors that followed. By mid-September, the region had endured more than 40 aftershocks exceeding magnitude 6, some strong enough to qualify as major quakes in their own right. The September 18th magnitude 7.8 event became only the latest chapter in a sequence that has held seismologists worldwide in rapt attention. To grasp why this clustering matters, one must understand how earthquakes redistribute pressure. A colossal rupture does not simply empty the system of energy, it reshapes it. Zones once stable find themselves newly strained, while others sink into temporary stress shadows where the likelihood of quakes falls. The danger with megathrust events is that they can set off cascading failures across enormous regions. The initial July rupture stretched nearly 600 kilometers along the boundary, yet the stress ripples it created extended far wider. Models by the United States Geological Survey indicate that scores of neighboring fault segments saw their risk heightened in the aftermath. By conventional reasoning, the September quake fits the textbook definition of an aftershock, a large but expected tremor born of stress changes triggered by the earlier cataclysm. And yet timing has its own gravity. The September 18th shock struck just 3 days after a Category G3 geomagnetic storm had surged through Earth's magnetic shield. Could this be only coincidence? Or might there exist some uncharted link between the planet's electrical environment and the mechanical stresses grinding within its crust? To entertain that question, we must first retrace those September days. The storm began on the 14th, when a high-speed stream flowing from a coronal hole slammed into Earth's magnetosphere. Unlike the explosive strike of a coronal mass ejection, this was a slow, persistent pressure building over 48 hours. Instruments on the ground captured magnetic fluctuations peaking at G3 strength, enough to paint auroras across vast latitudes and disrupt radio signals. More quietly, the storm drove telluric currents through Earth's crust, subsurface electrical flows that trace geological fractures and can at times reach startling intensities along vulnerable fault lines. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center chronicled the storm in remarkable detail. Solar wind speeds surged close to 700 kilometers per second, while particle density collapsed to fewer than 1 proton within a cubic centimeter. Such conditions create what some specialists describe as a solar wind vacuum, a rarefied low-pressure state that, according to alternative theories, might influence tectonic systems through electromagnetic coupling. But here we must step carefully. The notion that solar tempests could ignite earthquakes remains one of the most contentious debates in modern seismology. A sweeping review published in the Journal of Geophysical Research concluded that, once strict statistical controls are applied, no meaningful correlation appears between geomagnetic disturbances and seismic events. And yet, scattered studies have found faint hints of connection under narrowly defined circumstances. Advocates point toward shifts in atmospheric pressure, ionospheric disruptions, or currents induced in Earth's crust as possible triggers for quakes already teetering on the edge of failure. That last phrase is critical. Close to failure. No one argues that cosmic weather can manufacture earthquakes in tranquil crustal regions, but in September of 2025, Kamchatka was anything but tranquil. The landscape was still trembling from the July megathrust, and aftershock activity was unfolding in predictable cascades. Such sequences usually decline, according to statistical power laws. Patterns observed across thousands of historic earthquake swarms. What sets the September 18th shock apart is not its existence. Such aftershocks are expected following magnitude 8.8 ruptures, but its uncanny timing relative to the geomagnetic storm. To know whether this alignment falls within coincidence or points towards something deeper requires rigorous statistical examination. Several physical pathways have been proposed to explain how space weather might advance the clock on seismic failure. Geomagnetic storms can generate electric currents along conductive geological pathways, subtly altering pore pressure within fault zones. Ionospheric heating can produce changes in atmospheric pressure that ripple downward into the crust. Some even speculate that electromagnetic variations may affect the circulation of fluids locked deep within tectonic boundaries. Yet even if such mechanisms operate, they do not conjure earthquakes from nothing. At most, they can nudge unstable systems already primed to break. Shifting the timing rather than the inevitability of rupture. From these seismic episodes emerges another field of science that demands attention: tsunami forecasting. The July 29th cataclysm served as a real-world proving ground for next-generation monitoring networks. NASA's Guardian system, harnessing the precision of GPS satellites to track ground motion in real time, supplied vital information within minutes of the rupture. Combined with conventional seismic networks and the sentinel buoys of the DART array, scientists were able to map the energy of the quake as it coursed through Earth's crust and the overlying waters. The waves generated raced across the Pacific in under 10 hours, a sobering demonstration of how swiftly oceans can transmit destruction. From Alaska to Chile, coastal populations received warnings in advance. Proof of the progress in international coordination since the catastrophic Indian Ocean tsunami of 2004. Looking ahead to the final months of 2025, seismologists are watching Kamchatka with heightened vigilance. Statistical models still assign measurable probabilities for further large aftershocks, numbers that will decline only gradually with time. Yet here is what those traditional models cannot encompass. We now approach a cosmic convergence without precedent. An interstellar comet unfurling a coma hundreds of thousands of kilometers wide is preparing to meet a sun entering the fevered peak of its 11-year cycle. If the idea of electromagnetic coupling between space weather and seismic unrest holds even a trace of truth, and that remains a very large if then the weeks ahead could offer the most revealing test case science has ever encountered. The true question is not whether correlation equates to causation, but whether the alignment of events grows so striking that it demands earnest investigation. Beneath Kamchatka, the crust remains unsettled, its fault systems still straining and shifting under the colossal stresses unleashed on July 29th. Overhead, the space weather environment grows more volatile as Solar Cycle 25 climbs toward its fiery peak, and in the silent gulf between planets, 3I Atlas presses onward on its timeless voyage, closing in on its rendezvous with the Sun. What might occur when these three realms, geological, solar, and interstellar, intersect within the same brief span of history. The Kamchatka Peninsula may soon deliver that answer, whether humankind is prepared to face it or not. Part 3. The Earthquake Generator. There is something curious taking place in the near-Earth environment. An invisible drama most people never imagine. At this very moment, our planet drifts through a river of charged particles, streaming outward from the sun at such speed it could cross the continental United States in less than 20 seconds. This is the solar wind, a relentless outflow that has bathed Earth for billions of years. Yet this river is far from steady. At times it slows, at times it accelerates, and on rare occasions it forges conditions so peculiar that a handful of researchers believe it may even shake the ground beneath our feet. To unravel this possibility, we must understand coronal holes. Picture the sun not as a uniform ball of fire, but as a restless magnetic tapestry, with field lines weaving in both open and closed loops. Usually these lines arch back into the solar surface, imprisoning plasma in glowing arcs we admire as prominences. But in coronal holes, the lines thrust outward into space, forming direct magnetic highways that allow particles to escape. The result is a torrent of matter rushing at speeds above 700 kilometers per second, nearly twice the normal solar wind. This is where earthquake researchers take notice. As these fast streams sweep past Earth, they can create what some call a solar wind vacuum, particle density plummet, sometimes dipping below a single proton per cubic centimeter. For comparison, every cubic centimeter of the air you breathe holds 25 billion molecules. The vacuum of space in these moments is emptier than anything built in human laboratories. According to one controversial hypothesis, such conditions may do more than thin out space. They might coax large earthquakes from the Earth itself. The reasoning unfolds like this. Earth's crust is perpetually strained by tectonic forces, faults accumulating energy until they yield. But what if external electromagnetic fields could hasten the breaking point? What if the planet's electrical environment, shaped by solar wind conditions, provides the smallest nudge required to make a fault already on the verge of failure finally rupture? The chain of effects proposed begins with the solar wind compressing and stretching Earth's magnetosphere. These shifts trigger geomagnetic disturbances that in turn induce currents in Earth's conductive layers, the ionosphere above, the mantle below. These induced telluric currents flow invisibly through the crust, snaking along paths of least resistance. Utility companies track them closely, since they corrode pipelines and damage transformers. Could they also influence faults? The suggestion is not entirely implausible. Earthquake triggering is an established field within mainstream seismology. Scientists already know that minuscule stress changes from tides, atmospheric pressure, or even groundwater removal can tip a fragile fault into motion. The lingering question is whether electromagnetic effects can reach the same threshold of influence. September of 2025 offered a chance to observe. A coronal hole known as CH1316 funneled high-speed solar wind toward Earth for days, producing the telltale mix of accelerated velocity and reduced density. The ensuing G3 geomagnetic storm was not record-breaking, but its persistence was unusual. Magnetometers detected fluctuations that lasted more than 48 hours. while global ionospheric monitors traced ripples circling the planet. 3 days later, Kamchatka was rocked by a magnitude 7.8 earthquake. Correlation does not prove causation. A truth every scientist holds firmly. Kamchatka was already reeling with aftershocks from July's magnitude 8.8 rupture. From a statistical perspective, large aftershocks were not just plausible but anticipated. Yet the timing has drawn the attention of researchers exploring these connections. Their analyses suggest that major earthquakes tend to cluster during periods of reduced solar wind density, those vacuum conditions produced by coronal hole streams. The mechanism they envision begins with the magnetosphere expanding under lowered external pressure. That expansion reshapes the vast electric currents linking space to Earth's upper atmosphere, which then alters the telluric flows coursing through the crust. In areas where faults intersect with conductive rock, such changes might influence pore fluid pressure, tweak the electrical behavior of fault materials, or subtly concentrate stress. On an absolute scale, the forces are small, but faults near the breaking point are exquisitely sensitive to such nudges. The evidence presented in support comes largely from statistical comparisons of earthquake catalogues with space weather archives. Some studies report correlations with storm intensity, others with specific solar wind features like velocity or density. Yet mainstream seismology remains deeply skeptical. Unconvinced that the patterns rise above coincidence, the United States Geological Survey, steward of the world's most extensive earthquake archive, maintains an unambiguous stance. No causal link has been demonstrated between space weather and seismic activity. This position, grounded in numerous independent analyses, insists that the correlations claimed in some studies collapse once rigorous statistical controls are applied. The central challenge is untangling authentic signals from illusions born of large datasets. Earthquake catalogues contain thousands of recorded events, while space weather archives track continuous fluctuations across dozens of parameters. With so many variables available for comparison, spurious alignments can appear almost inevitably, even when no underlying relationship exists. Critics highlight several flaws in research, attempting to connect the two domains. Selection bias can color which earthquakes or intervals are chosen for study. Multiple comparison effects mean that examining many potential correlations raises the odds of stumbling upon false positives, and the physical mechanisms proposed often lack firm grounding in laboratory results or robust theoretical modeling. Yet proponents counter with a different perspective. They argue that the persistence of reported correlations appearing across varied datasets, regions, and analytic approaches suggests that something genuine may be at work. They cite controlled experiments where electromagnetic fields have altered rock mechanics, as well as the growing realization that Earth's electrical environment is far more dynamic and intricate than once believed. The solar wind vacuum hypothesis represents one effort to provide a tangible framework by focusing on specific conditions: low density, high-velocity streams emanating from long-lived coronal holes. It lays out predictions that can be tested, with solar cycle 25 surging toward its peak. Opportunities for such testing abound. Coronal holes become more frequent and persistent during solar maximum, ensuring repeated encounters with high-speed streams. Meanwhile, today's geomagnetic monitoring offers unprecedented precision, recording the electromagnetic backdrop of seismic events in exquisite detail. The sequence of September 2025 offers one such data point. A persistent coronal hole stream generated classic vacuum conditions, and within days, a major earthquake erupted in a region already primed for rupture. Does this alignment reflect causation, mere correlation, or nothing more than coincidence? The debate remains unresolved, and voices on both sides grow louder. What makes the coming months especially compelling is that the story does not end with solar activity alone. An interstellar wanderer, trailing a colossal plasma coma, now races toward its closest approach to our Sun. If electromagnetic coupling between the cosmos and Earth truly exists, 3I Atlas may soon provide the most dramatic experiment ever witnessed. The solar wind vacuum is no longer just an esoteric curiosity of heliophysics. It has become a potential key to understanding how our planet responds to the electrical pulse of the wider solar system. As October of 2025 approaches, that key may be tested as never before, whether the evidence strengthens the case for space weather triggering earthquakes or finally lays it to rest. One truth remains: the Earth beneath us and the plasma that flows past us are about to enter into a dialogue that could alter our vision of how the solar system truly functions. Part 4. Planetary alignment and the G3 storm. At times, the universe seems to possess a sense of timing worthy of Hollywood. On September 13th, 2025, Mercury slipped into superior conjunction, aligning in a flawless straight line behind the Sun as seen from Earth. Within a single day, a Category G3 geomagnetic storm slammed into our planet's magnetic shield, igniting curtains of green light that reached as far south as Kansas. Coincidence? According to mainstream heliophysics, the answer is unequivocal: yes. The storm was the obvious product of a high-speed stream escaping from a coronal hole that had been tracked for days. Mercury, stationed 96 million kilometers away on the far side of the Sun, could not possibly alter the solar wind coursing past Earth. Yet for those who entertain possibilities beyond the conventional, the story is more provocative. A minority of researchers argue that planetary alignments may shape the electrical environment of the solar system in subtle but meaningful ways. Gravity plays no role here; it is far too weak. Instead, they suggest an intricate lattice of electromagnetic connections linking all bodies within the heliosphere. To grasp this vision, one must reimagine the solar system not as isolated planets drifting through emptiness, but as a colossal electrical circuit. The Sun stands as the power source, streaming charged particles that carry currents across the heliosphere. Planets, with their magnetic fields and ionospheres, behave like components in a cosmic circuit. Resistors, capacitors, inductors, working on scales unimaginably larger than any engineered by humankind. When planets align, the theory goes, they may alter the overall impedance of this vast network. It is like adding or removing parts from an electronic device. The current pathways shift, and the entire system responds, often in unpredictable ways. The conjunction of Mercury on September 13th drew attention precisely because it occurred amid heightened solar activity. The Sun was climbing toward the crest of solar cycle 25, displaying swollen sunspot counts and erupting more frequently. Coronal hole CH1316 had already been channeling high-speed solar wind toward Earth for several days, priming conditions for disturbance. Forecasts called for a G2 storm of moderate intensity. Instead, ground magnetometers recorded a surge into G3 territory. The distinction may appear minor, but in space weather, the difference signifies a large leap in electromagnetic energy. G3 storms are the threshold where cosmic weather begins to intrude on daily life. Aurora ovals spread far from the poles, glowing over Colorado and Illinois. Radio operators reported blackouts in high-frequency bands vital to aviation and maritime navigation. GPS accuracy faltered as turbulence in the ionosphere scrambled satellite signals. Even more critical for this inquiry, storms of this scale inject strong geomagnetic currents into Earth's crust. These telluric currents slither through veins of water, mineral-rich layers, and conductive rock. Their pathways dictated by the geology itself. Their existence is not speculation. Utilities have tracked them for decades because they erode pipelines and overload transformers, sometimes triggering cascading failures in power grids. The unresolved question is whether these subterranean currents are powerful enough to affect earthquakes. Engineers working with transmission systems fret over currents measured in the hundreds of amperes. But some unconventional researchers contend that in the depths of Earth's crust, storms of great strength may drive currents numbering in the millions of amperes. The physics of how geomagnetically induced currents might influence earthquakes remains speculative, but several pathways have been proposed. Electrical currents coursing through fault zones could alter pore fluid pressure by changing the electrochemical properties of groundwater. They might shift the electrical breakdown thresholds of rocks, making slip more likely under stress. Or they could create localized heating that subtly weakens segments of fault planes. Mainstream geophysics views these scenarios with skepticism, largely because the energy involved appears far too small when compared to the immense mechanical forces that govern earthquakes. A single magnitude 7 rupture unleashes energy equal to 32 nuclear weapons, whereas the electromagnetic output of even severe geomagnetic storms represents only the tiniest fraction of that. Yet triggering does not require matching the full energy of an earthquake. Small changes in stress, measured in kilopascals rather than megapascals, can accelerate rupture timing if a fault is already poised to fail. The tidal tug of the moon provides a familiar example, nudging earthquakes into motion despite its forces being minuscule relative to tectonic loads. The central question is whether electromagnetic disturbances reach stress magnitudes similar to those tidal effects. Laboratory experiments have demonstrated that electric currents can influence how rocks fracture, but extending such results to natural fault systems remains an immense challenge. What makes the storm of September 14th so intriguing is its timing. Sandwiched between Mercury's Superior conjunction and the Kamchatka quake that followed days later, if planetary alignments modulate the heliosphere's electrical state, then these alignments might mark periods when electromagnetic coupling between cosmic weather and terrestrial processes intensifies. The mechanism envisioned works like this. Planetary alignments reshape the vast heliospheric current sheet. The spiral of electric current streaming outward from the solar equator. Those changes race outward at the speed of light, reaching Earth within minutes. When such altered structures encounter our magnetosphere during a geomagnetic storm, the effects may be amplified. Earth's magnetic field then channels the intensified currents into polar regions, linking them to the global web of telluric currents that snake through the solid crust. In tectonically restless regions like Kamchatka, these currents might provide just enough stress to trigger rupture along faults already near their limits. The effect would be subtle, advancing timing by hours or days rather than creating quakes from nothing. Testing this hypothesis demands careful statistical comparisons between earthquake catalogs, geomagnetic storm records, and planetary position tables. Preliminary studies have reported faint correlations, though their significance remains hotly debated. The September sequence provides a case study. Mercury's conjunction occurred less than 24 hours before the G3 storm struck. That storm endured for more than 2 days, sustaining electromagnetic fluctuations across the globe. 3 days later, Kamchatka erupted with its magnitude 7.8 tremor. Are these simply chance alignments, or traces of a deeper connection? The time intervals hours between conjunction and storm, days between storm and quake, fit with proposed triggering mechanisms. But they also fit with coincidence. As solar cycle 25 intensifies, chances to probe these ideas will multiply. Coronal holes will appear more often, sending frequent streams of high-speed solar wind. Planetary alignments will occur repeatedly, providing natural laboratories for comparison. Yet the decisive test may arrive in late October, when 3I Atlas sweeps through perihelion amidst a cluster of astronomical events. If electromagnetic coupling between solar weather and seismic activity is real, this convergence could yield the most compelling evidence to date. But that assumption rests on the belief that the effects are subtle and local. What if they are not? What if the electromagnetic environment of October proves strong enough to stir seismic unrest across multiple regions simultaneously? Then we step into uncharted territory, where the sun, comets, and planets together weave conditions never before documented. The shocks of September may prove only the prologue to a much grander cosmic performance. Whether that drama remains a curiosity of science or grows into something more consequential depends on questions humanity is only now learning how to frame. Part 5. The antipodal threat. There is a symmetry to our planet so elegant that few ever pause to consider it. From any point on Earth's surface, draw a line straight through the core and out the other side, and you reach its antipode, the precise opposite spot on the globe. For most places, that point lies deep in some remote ocean basin. But for the quake-ridden Kamchatka Peninsula, the story takes an intriguing turn. Its antipode falls remarkably close to the Drake Passage, one of the most tectonically restless corridors of the Southern Ocean. This geographical curiosity has sparked the imagination of scientists, exploring what they call the global balance of seismic energy. Their proposal is bold and only partly grounded in evidence. When great earthquakes erupt, they create stress imbalances that must eventually be resolved. And sometimes the resolution may unfold halfway around the world. The concept blends established geophysics with speculative geodynamics. It is certain that large earthquakes launch seismic waves that traverse the entire Earth. Long-period surface waves can circle the planet multiple times, carrying encoded details of magnitude, depth, and rupture dynamics to every seismic station. But could they carry more than information? Could they transport stress itself, slowly depositing it in distant fault systems until conditions ripen for another quake? The Kamchatka shock of July 29th, magnitude 8.8, offered the perfect test. Its energy reverberated across every continent, with instruments still registering motion 12 hours later. The waves circled the globe repeatedly before fading into the ever-present hum of background seismic noise. Along their journey, they threaded through the planet's great fault networks, from transform boundaries to mid-ocean ridges to subduction zones. The Drake Passage stands out in this chain, situated at the meeting of the Antarctic, South American, and Scotia plates. It is a crucible of tectonic stress, where unpredictable ruptures often occur. Advocates of the antipodal hypothesis argue that the energy unleashed in Kamchatka may have been delivered to this southern arena, priming it for a delayed reaction. The details of the mechanism remain obscure, perhaps direct stress transfer through deep mantle pathways, perhaps resonance effects amplifying local strain, or perhaps interactions with Earth's magnetic and electrical properties yet to be fully described. What excites proponents most is the timing. By analyzing past earthquake pairs, they suggest that antipodal responses often occur 2 to 6 months after the initiating shock. That places October and November of 2025 squarely within the expected window. Yet caution is essential. Mainstream seismology does not accept antipodal triggering as a proven process. Agencies like the United States Geological Survey construct forecasts using local geology, stress accumulation rates, and regional statistical models. Global stress transfer certainly exists. Massive earthquakes do redistribute forces across thousands of kilometers, but the influence weakens predictably with distance, following equations that depend on crustal structure and fault geometry. For antipodal triggering to occur, stress would need to traverse 12,700 kilometers of solid Earth, the longest distance possible between two surface points. Seismic waves can indeed travel that far, but whether they could deliver enough concentrated energy to destabilize distant faults remains highly doubtful. The difficulty lies in the energy budget. A magnitude 8.8 quake releases on the order of 10 to the power of 17 joules, roughly 32 megatons of TNT. But the overwhelming majority of that energy dissipates locally as heat and seismic radiation by the time waves reach the antipode. The remaining fraction is vanishingly small compared to the immense tectonic forces that dictate rupture. Still, proponents cite suggestive examples. The Great Sumatra earthquake of December 2004 was followed 4 months later by an 8.6 event on the same plate boundary. The Tohoku quake of March 2011 coincided with anomalous seismicity in several antipodal regions. Though no single giant rupture emerged, some researchers have even proposed statistical correlations linking activity around the Pacific Ring of Fire to disturbances along the Mid-Atlantic Ridge. If such links prove real, they would point toward planetary-scale stress transfer mechanisms not yet integrated into orthodox seismology. This is why the Drake Passage matters. Its geology is uniquely complex. A knot of converging plates and volatile boundaries. If the antipodal hypothesis has merit, it is here, in these southern waters, that the echoes of Kamchatka may one day reveal their hand. The Drake Passage is the youngest oceanic gateway on Earth, having opened only 34 million years ago when South America and Antarctica finally tore apart. That relatively recent origin means its fault systems are still settling into their new tectonic architecture. Today, the region experiences routine quakes along the South American Antarctic ridge. most in the magnitude 5 to 7 range. Yet the intricate interplay of spreading ridges, transform faults, and the nearby South Sandwich subduction zone creates conditions where far larger ruptures cannot be ruled out. If the concept of antipodal energy transfer holds any truth, the Drake Passage would be a natural place to search for signs in the months ahead. A regional spike in seismic activity across several fault systems would suggest broad stress redistribution rather than localized release. Shifts in earthquake focal mechanisms, the orientation of rupture planes, might point to altered stress fields, and any major tremor would need to arrive within the narrow window predicted for antipodal responses. The hypothesis gains further complexity when an electromagnetic layer is added. Some researchers argue that antipodal triggering may not be purely mechanical at all, but could involve electrical disturbances spreading through Earth's conductive interior. This line of thought links the global energy balance of seismicity to the electromagnetic theories already under discussion. In this model, the Kamchatka megaquake generated not only seismic waves, but also electrical perturbations transmitted through the mantle and core. These disturbances might influence faults at great distance through the same processes suggested for space weather, altering pore fluid pressure, changing electrical breakdown thresholds of rock, or creating pockets of localized heating. Unlike the slow redistribution of mechanical stress, electrical signals can move at substantial fractions of light speed through conductive media, raising the possibility that antipodal effects could emerge within hours or days rather than months. Testing such claims demands detailed comparisons of worldwide seismic records against electromagnetic monitoring data. A few research groups have reported intriguing hints, but skepticism remains strong. The signal-to-noise ratio in global earthquake catalogs is formidable, and with so many variables in play, establishing causal links is extremely difficult. What makes the present moment so compelling is the convergence of potential drivers. The Earth is still rattling from Kamchatka's aftershocks. The Sun is approaching the fevered maximum of solar cycle 25, and an interstellar visitor, 3I Atlas, races toward perihelion wrapped in a vast electromagnetic coma. If antipodal triggering exists, this confluence may present the most powerful test case ever observed. Mechanical stresses from Kamchatka, electromagnetic surges from solar storms, and possible interactions with an alien plasma cloud could, in theory, combine to shape seismic outcomes across multiple regions. The Drake Passage is only one possible locus for such effects. Other antipodal counterparts to recent major quakes lie in the Atlantic and Indian Ocean basins, where transform fault networks may also be sensitive to global stress perturbations. The key will be to watch for patterns that rise above ordinary background levels while falling within predicted time windows. Throughout October and November of 2025, seismologists worldwide will monitor these areas with unusual vigilance, not necessarily because they accept the antipodal model, but because the convergence of so many rare circumstances has created an unparalleled natural experiment. Whatever the verdict, the data gathered will enrich our understanding of how Earth responds to energy, both internal and external. Our planet is an intricately connected system, where disturbances in one place can ripple across vast distances, and as evidence now suggests, it may even respond to influences arriving from beyond our solar system. The energy balance hypothesis imagines Earth striving to maintain a kind of seismic equilibrium, where massive disruptions in one region compel compensating events elsewhere. If that vision is true, then the Kamchatka quake of July has set in motion an imbalance still awaiting resolution. The question is not whether the planet will answer, but where, when, and whether we will recognize the response when it comes. Part 6. The anomalous interstellar object. In the 1970s, astronomer Carl Sagan reminded us that extraordinary claims demand extraordinary evidence. By that standard, 3I Atlas confronts us with a riddle worthy of the cosmos. This is not simply another comet drifting through our system. It is a visitor from the abyss, carrying chemistry and matter forged in the furnaces of stars light years away. Its very designation tells the tale, 3I Atlas, where the letter I marks it as interstellar, and the number 3 declares that it is only the third confirmed traveler ever observed crossing into our solar system from the deep beyond. The first, 1A Oumuamua, astonished astronomers in 2017 with its elongated shape and unexplained acceleration. The second, 2I Borisov, appeared 2 years later, behaving more like a conventional comet. 3I Atlas falls somewhere between the familiar and the extraordinary, and it is that tension that makes it so captivating. Its discovery in 2025 came through the Asteroid Terrestrial Impact Last Alert System, which first spotted a faint blur moving against the stars. Orbital calculations quickly revealed this was no ordinary asteroid and no familiar comet. Its path was unmistakably hyperbolic, a trajectory that could only belong to something born beyond the sun's grasp. From the very beginning, it defied expectations. Most comets lie dormant until they wander within 2 or 3 astronomical units of the Sun, near the asteroid belt, yet even at much greater distances. This object was already active. The Hubble Space Telescope confirmed what ground-based observers had suspected. 3I Atlas was developing a coma, the ethereal shroud of gas and dust that gives comets their ghostly glow. But by all conventional physics, such activity should have been impossible at that distance. Stranger still were the shapes revealed in Hubble's extended observations. Typical comets display comas centered neatly around their nuclei. But this interstellar traveler showed forward brightening, its brightest halo shimmering ahead of its solid core. This suggested complex jets and outgassing patterns, perhaps driven by rotation or exotic surface properties unknown among the comets of our own system. Spectroscopy brought another revelation. While most local comets are composed chiefly of water ice, with minor traces of carbon monoxide and carbon dioxide, 3I Atlas presented an unusually rich carbon dioxide signature. That chemistry fits an object born in the frigid void between stars, where carbon dioxide remains frozen while water may be depleted by other processes. Yet what truly sets this wanderer apart is scale. Hubble's measurements, coupled with thermal modeling, suggest its nucleus is modest by cometry standards, between 3 and 6 kilometers across. Substantial, but not extraordinary. Its coma, however, is staggering in size. Current estimates place its envelope at 348,000 kilometers from the center, forming a sphere some 700,000 kilometers wide. Imagine lining up 50 Earths across the ghostly width of its shroud. In scale, It is comparable to the greatest structures in the solar system. The Sun itself measures 1.4 million kilometers across. 3I Atlas has spread a luminous bubble half that size. The physics behind such an enormous display from such a small body likely lies in its interstellar origin. Unlike local comets, weathered by billions of years of solar radiation and planetary encounters, this object carries pristine material from its natal star system. Its ices may be unusually volatile, releasing gas in torrents, even at great distances from the Sun. The result is a haunting apparition, a diffuse bubble of alien chemistry moving through our skies, challenging every intuition we hold about the nature of comets. The spin of the object appears to be a crucial factor in its strange behavior. Early measurements suggest a rotation period of several hours, unremarkable for small bodies. Yet the surface seems anything but uniform. Some patches may be saturated with volatile ices ready to sublimate, while others remain barren and inert. This patchwork terrain could explain both the irregular shape of the coma and the remarkable forward brightening seen in telescopic images. As 3I Atlas closes in on its perihelion on October 30th, solar heat will intensify, releasing ever more ice from surface and subsurface layers. Models predict that the already vast coma could balloon to more than 1 million kilometers across, potentially outgrowing the Sun itself in breadth. What makes this prospect even more captivating is that the coma is no passive veil of gas and dust. It is alive with plasma physics, a charged structure in constant conversation with the solar wind and the interplanetary magnetic field. As the Sun's stream of particles collides with neutral atoms in the coma, electrons are stripped away, leaving ions to dance under magnetic forces, swept outward by the solar wind. These ions give rise to the luminous ion tail that forever points away from the Sun. For an object whose coma already spans hundreds of thousands of kilometers, this interaction zone is colossal. 3I Atlas is dragging an immense electromagnetic net through the solar wind, a net exquisitely sensitive to changes in magnetic strength, particle density, and plasma heat. In effect, the comet has become an interstellar probe of the heliosphere itself. The timing could hardly be more fortuitous. Solar cycle 25 is racing toward its maximum, marked by eruptions, high-speed streams, and turbulent plasma flows. The heliosphere has not been this restless in more than a decade, providing 3I Atlas with a shifting laboratory of space weather conditions. NASA's James Webb Space Telescope has been tracing its spectroscopic fingerprint, while ground-based facilities track the changing structure of its coma and the birth of its tails. Meanwhile, the European Space Agency's Solar Orbiter samples solar wind conditions from within, offering a parallel view as the interstellar traveler drifts through the Sun's dynamic fields. What unfolds is nothing less than a grand experiment in plasma physics, on a scale impossible to reproduce on Earth. But the significance of 3I Atlas transcends science alone. Its presence reminds us that our solar system is not sealed off from the galaxy. Objects like this wander between stars, carrying with them the frozen chemistry of alien nurseries and the physical signatures of other suns. To study 3I Atlas is to receive a direct delivery of interstellar material, a message from far beyond, and some researchers are asking whether the message might extend further still. Its vast electromagnetic presence and peculiar responses to the solar wind have inspired speculation that interstellar visitors may influence space weather in measurable ways. Such possibilities verge on the exotic, hinting that these travelers may do more than simply pass through. They may, in subtle ways, interact with the systems of planets they encounter. For now, 3I Atlas presses on in its ancient journey, brightening and stirring as it approaches the Sun, whatever secrets it holds of chemistry, of plasma, of distant origins. It is about to reveal them in dramatic fashion. The universe has sent a messenger from the deep between stars. The only question is whether we will recognize the language in which it speaks. Part 7. The Coma. Half the diameter of the Sun. Imagine, if you can, a soap bubble adrift in space, yet a bubble so vast it could swallow 25 Earths with room left over. That is the staggering scale of the coma surrounding 3I Atlas, a gauzy envelope of gas and dust whose growth is pushing the limits of what we thought comets could become. The newest readings from infrared space telescopes reveal dimensions that seem almost beyond belief. The coma now stretches at least 348,000 kilometers from the nucleus, creating a sphere some 700,000 kilometers across. To place this in cosmic context, this alien visitor has inflated a bubble spanning more than half the breadth of our own Sun. That comparison is more than a striking statistic. It is a reminder of two very different kinds of physics operating on two very different scales. The Sun is a roaring furnace of plasma, bound by gravity and blazing at millions of degrees within its heart. 3I Atlas is a frozen shard of ice and rock, no larger than a small mountain. Yet it has sculpted a structure rivaling a star in size by means of entirely different processes. The key lies in the nature of cometary comas. When we see a comet's glowing head in the sky, it is not the solid nucleus we are witnessing, but the cloud of material liberated by sunlight. Ices sublimate directly from solid to vapor, dragging dust along in their escape, and the mixture expands outward to form a hazy sphere. For the comets native to our solar system, this awakening usually begins only when they cross inside the orbit of Jupiter. Within 5 astronomical units of the Sun, the coma reaches its largest size near perihelion, then contracts as the comet retreats back into the cold. But 3I Atlas has defied these conventions. It began showing activity while still farther than 3.8 astronomical units from the Sun, a distance where heat should scarcely register. This premature stirring points to an unusual chemistry. Spectroscopy has revealed that, unlike local comets dominated by water ice, with faint traces of carbon monoxide and carbon dioxide, 3I Atlas is rich in carbon dioxide and other exotic ices. These compounds sublimate at much lower temperatures than water. On Earth, carbon dioxide ice turns to gas at about -78 degrees Celsius. But in the near vacuum of space, sublimation begins at even lower temperatures, driven only by faint sunlight. For months now, this process has been feeding the comet's massive halo, grain by grain, molecule by molecule, long before it nears its closest approach. Yet sheer size does not tell the whole story. The coma is not a placid sphere. It is a dynamic environment where forces collide. Solar radiation pressure pushes dust outward, sculpting the broad dust tail that can extend millions of kilometers behind the comet. At the same time, the solar wind, a torrent of charged particles, rushing outward at 400 kilometers per second, strikes the neutral gases of the coma through photogenization. Photons knock electrons from atoms, creating ions that respond to magnetic fields. Swept away, these ions stream off to form the comet's blue tail, always pointing directly away from the sun, no matter how the comet moves. For a body with a coma spanning hundreds of thousands of kilometers, this ionization process establishes an immense arena of plasma chemistry. Think of 3I Atlas as casting a colossal net through the solar wind, one that constantly samples the electromagnetic environment of our star. Changes in speed, density, or magnetic intensity shape the responses of the coma during periods of heightened solar activity, such as the storms seen in recent weeks. The interactions grow even more complex and violent. The comet's strange forward brightening adds another layer to the mystery. Instead of a symmetric glow centered on the nucleus, its brightest light shines ahead of its orbital path, hinting that outgassing is concentrated on select patches of its rotating surface. This asymmetry suggests a body with a heterogeneous composition, perhaps scarred by different histories of formation and preservation, making 3I Atlas unlike any comet we have studied before. As 3I Atlas spins, different regions of its mottled surface turn toward the sun, releasing bursts of volatile gas that sculpt shifting features within the coma. These structures can linger for days or even weeks, producing an ever-changing landscape of dust and vapor shaped by both solar heat and the comet's own rotation. The sheer scale of this activity becomes clear when considering the mass loss involved. Current estimates suggest the comet is shedding several kilograms of material every second. That may sound trivial, yet stretched over months, it amounts to thousands of tons of pristine interstellar substance dispersing across the inner solar system. Each grain and molecule carries the chemical fingerprint of the stellar nursery where this wanderer was born billions of years ago. Spectroscopy of the coma thus provides something unparalleled, a direct sample of interstellar chemistry, offering clues to conditions around other suns that no probe or telescope could otherwise reveal. But the coma is more than just a scientific treasure chest. It is also an electromagnetic engine on a scale we have never studied before. The ionized portion creates a vast expanse of plasma, a natural laboratory where charged particles interact with magnetic fields under conditions impossible to reproduce on Earth. Some researchers now speculate that objects like 3I Atlas might serve as natural modifiers of space weather. Their colossal comas, acting as plasma reservoirs capable of amplifying or damping disturbances in the solar wind. The notion remains speculative, yet the immensity of the interaction zone makes it a possibility worth considering. As October 30th perihelion approaches, this spectacle is only intensifying. Solar heating will strip away even more buried ice, and models suggest the coma may expand to over 1.2 million kilometers in diameter, larger than every permanent structure in the solar system, save the sun itself. Yet its visibility from Earth is deceiving. For all its grandeur, the coma is extraordinarily diffuse, its particle density far lower than the thin air at the edge of our own atmosphere. Most of the solid material collects in the dust tail, which skilled observers may glimpse through telescopes as the comet curves around the sun. The real drama, however, unfolds at invisible wavelengths. Radio telescopes capture signals from the ionized gases. Infrared observatories track the faint heat of dust grains warmed by sunlight. X-ray instruments register violent processes where solar wind crashes into the coma's edge. Together, they reveal a lesson in plasma physics written across interstellar canvas. 3I Atlas has become a natural experiment, a chance to observe electromagnetic interactions on scales that dwarf any laboratory. It is showing us, in real time, how matter and energy converse in the charged environment around our star. Yet it presents raise a deeper question. Is this comet merely a passive shard of ice and stone? Or can an object capable of generating such an enormous electromagnetic footprint also influence the very space weather it samples? That possibility pushes us into a liminal zone where science meets speculation, where the line between natural phenomena and imagined technologies begins to blur, forcing us to confront how little we truly know about what is possible in the universe. Part 8. What if 3I Atlas is an alien energy harvester? Let us step deliberately into speculation. Though speculation grounded in physics rather than fantasy, what if 3I Atlas is not merely a fragment of ancient ice and stone drifting from another star? What if it is something far more extraordinary, an engineered construct, a vast energy harvesting device crafted by an intelligence beyond our comprehension, designed to draw power from suns as it journeys between stellar systems? At first, the idea sounds like pure science fiction, but the evidence we have already traced lends it a strange plausibility. A nucleus only 3 to 6 kilometers across, producing a coma 700,000 kilometers wide. A structure smaller than a mountain generating an active zone more than 100,000 times larger. To an engineer, that efficiency might look less like chance and more like design. The coma begins to resemble not random outgassing, but a deliberately deployed plasma sail, a gossamer net stretched across space to intercept and channel stellar energy. The underlying physics is not impossible. We already know how electromagnetic fields accelerate charged particles, the same principle behind plasma thrusters and magnetic confinement fusion. Imagine that 3I Atlas is a scaled-up version of such technologies, built to operate directly in the plasma streams of stars. The peculiar forward brightening, so difficult to explain by natural cometry processes, could represent controlled guidance rather than chaotic jets. Precision outgassing used to adjust trajectory or optimize solar wind capture. Even the carbon dioxide-rich composition gains new significance. Unlike water, which requires substantial heating to sublimate, carbon dioxide transitions from solid to gas at low temperatures, making it an ideal propellant for a system that must remain active across a wide range of stellar environments. Energy harvesting, however, would demand more than an oversized coma. There must be a way to channel captured energy into useful work. Here the physics becomes intriguing. The very process that generates ion tails in comets could, in principle, to be engineered to produce electrical currents on an unprecedented scale. As the solar wind ionizes neutral atoms in the coma, charged particles are created that respond to magnetic fields. In an ordinary comet, these ions are swept away. But if 3I Atlas contained magnetic field generators embedded within its core, they could steer ions along controlled pathways, operating like a planetary-sized magneto-hydrodynamic generator. The result would be a system converting the kinetic energy of solar wind particles directly into electricity. The potential scale of such an engine is staggering. The collection cross-section spans millions of square kilometers, while particle velocities routinely exceed 500 kilometers per second. At Earth's orbit, the solar wind carries roughly 10 to the power of -3 watts per square meter. For an active zone the size of 3I Atlas's coma, that translates into potential terawatts of power, hundreds of Earth's largest power plants combined. Efficiency would be the key. Natural plasma interactions dissipate most energy as heat and radiation, but an engineered system might employ superconductors or exotic field configurations to achieve efficiencies impossible in nature, channeling vast currents to a central processing core. The question then arises, what purpose would such a staggering energy supply serve? One possibility is storage. Perhaps in exotic states of matter or high-energy particle reservoirs capable of persisting through the interstellar night. Another is propulsion, using collected energy to accelerate propellant and alter the object's trajectory between stars. From the standpoint of strategy, such a system makes sense. Stars are the most concentrated sources of energy in the galaxy. A civilization able to deploy collectors across stellar systems would gain an immense advantage in exploration and colonization, and the functions might extend beyond power and propulsion. A device of this kind could double as a communication relay, a scientific probe, or even an autonomous explorer operating for millions of years, following routes mapped out long ago by its creators, whether natural or artificial. 3I Atlas offers us a vision of what might be possible, a messenger from the interstellar deep, or perhaps a machine designed to harvest the light of suns. In the 1940s, mathematician John von Neumann imagined a bold idea, self-replicating machines that could spread through the galaxy, drawing upon the raw materials and energy of every stellar system they encountered. These so-called von Neumann probes became a cornerstone of theoretical discussions about interstellar exploration. 3I Atlas might represent a subtler cousin of that vision, not a replicator, but a self-sustaining traveler, harvesting energy from stars to power its endless journey. Yet here we must pause and apply a dose of skepticism. If 3I Atlas were truly artificial, we might expect to see unambiguous signs, spectral lines from exotic materials, non-thermal radiation patterns, trajectories deviating from what gravity and natural outgassing can explain. So far, the evidence points toward a natural comet, albeit one of unusual scale. Its spectroscopic signature displays familiar lines from sublimating ices. Its path follows a hyperbolic arc, entirely consistent with ejection from another star. Even the non-gravitational accelerations that puzzled us with 1I Oumuamua could be accounted for by asymmetrical outgassing, rather than alien propulsion. The ultimate test would be technology signatures, artificial alloys, coherent electromagnetic emissions, or patterned behaviors hinting at deliberate control. Radio telescopes have scanned 3I Atlas for such anomalies, but the results remain ordinary. Emissions no different from those produced by plasma interactions around any large comet. Yet the absence of obvious signals does not necessarily settle the question. A sufficiently advanced civilization could design probes to appear indistinguishable from natural bodies, mimicking comets so perfectly that primitive observers would never guess their true purpose. Such camouflage could be scientific, to avoid contaminating observations of natural systems; strategic, to avoid notice by younger civilizations; or defensive, to conceal capabilities from potentially hostile species. From this perspective, the very naturalness of 3I Atlas could itself be the mark of deliberate design. Its timing raises further questions. The comet's perihelion arrives during the peak of solar cycle 25, when the sun unleashes its greatest storms and the solar wind flows with maximum energy. Coincidence or calculated choice? A probe optimized for stellar energy harvesting might deliberately time its closest approach to coincide with such conditions, ensuring the richest electromagnetic environment to exploit. In this light, the plasma interactions we have been tracing throughout this investigation take on new significance. If 3I Atlas were gathering energy on such a scale, it might leave electromagnetic ripples strong enough to influence space weather across the inner solar system. Such effects could be intentional experiments to test how planetary magnetospheres respond, or they could be byproducts, unavoidable consequences of harvesting energy in an environment so vast. The correlations we have examined between geomagnetic storms and seismic activity take on a provocative edge under this hypothesis. What if the quakes were not merely natural reactions to solar wind fluctuations, but subtle responses to artificial modulation? Could it be that 3I Atlas is not simply harvesting energy, but conducting a survey deliberately stimulating Earth's electromagnetic systems to observe how its crust and oceans respond? The notion borders on the fantastic, yet it forces us to ask whether what we are witnessing is accident or design, even if such possibilities stretch beyond conventional science. The implications are profound. Whether 3I Atlas proves to be nothing more than a shard of ancient ice or a carefully crafted machine, its passage grants us an unprecedented chance to watch plasma physics unfold on a cosmic scale. The question is whether we will recognize what we are truly seeing, or whether we will let the moment pass without grasping the deeper meaning hidden in its luminous veil. Part 9. Earthquakes as directed energy. This is where our investigation veers into territory that could make even the steadiest seismologist reach for medication. What if the earthquakes we have been tracing are not merely natural convulsions of Earth responding to space weather? What if they are the product of something more calculated, directed energy effects, systematically probing the crust with the precision of an experiment? At first, the suggestion feels absurd, yet the patterns we have examined refuse to fade into coincidence. High-speed solar wind streams generate low-density vacuum conditions that some researchers argue can trigger quakes on faults already primed to rupture. The timing correlations are striking. Even if mainstream science still resists the mechanisms, but what if those vacuum conditions are not fully natural? What if advanced technology could modulate the solar wind itself, shaping the electromagnetic environment to nudge seismic systems on a planetary scale? To entertain this possibility requires us to think in magnitudes far beyond ordinary human intuition. We are used to earthquakes as chaotic events, driven by the slow accumulation of tectonic stress over decades or centuries. The idea that external electromagnetic fields could pull the trigger seems to upend everything we know about geology. Yet the energy calculations are not as impossible as they sound. An earthquake unleashes energy on the scale of hundreds of nuclear detonations, but that energy is already stored in the crust. Triggering does not require matching it, only adding a fraction of stress. The final push that tips a loaded system into failure. Laboratory experiments have shown that electromagnetic fields can influence rock fracture. Electric currents through rock samples change mechanical properties, alter pore fluid pressures, and generate localized heating that shifts thresholds for failure. The real question is whether these effects, observed at bench scale, could be magnified to act on natural fault systems. If a technology wished to study a planet's seismic architecture, systematic triggering would be an efficient method. By creating controlled electromagnetic conditions and watching how the crust responds, it could map stress states, fault geometries, and transfer dynamics in exquisite detail. The historical record offers some provocative hints. When 1I Oumuamua passed near the Sun in September 2017, Mexico endured a magnitude 8.2 quake within days. The devastating Tohoku earthquake of March 2011 came amid heightened solar activity and geomagnetic storms in the preceding weeks. These links prove nothing. Of course, earthquakes are common, as are space weather events during solar maxima. Patterns will appear when combing decades of data, yet they grow more intriguing when placed against the backdrop of global distributions. The 2004 Sumatra disaster, the 2010 Chile quake, and Japan's 2011 catastrophe all unfolded during periods of intense solar activity. Some even displayed precursor signals, shifts in groundwater, electromagnetic anomalies, and atmospheric disturbances that could, in theory, result from deliberate electromagnetic probing. If 3I Atlas is not a comet but a probe, its immense electromagnetic presence offers an ideal testing ground. Its coma spans hundreds of thousands of kilometers, creating a plasma interaction zone larger than most planets. In principle, such a system could focus and direct electromagnetic effects across enormous volumes of space. The required technology need not break physical law. Superconducting coils could manipulate magnetic fields into focused beams. Plasma injection systems could sculpt the solar wind, creating the very vacuum states linked to earthquake triggering. The precise timing observed between geomagnetic events and seismic activity could then represent not coincidence, but design an advanced understanding of fault loading cycles and stress thresholds. Such a system might watch Earth continuously, waiting for just the right instant, when a minor perturbation could unleash a major quake, and it could act through multiple mechanisms at once, layering effects to maximize response. High-frequency electromagnetic pulses could alter the electrical behavior of fault-zone minerals. Low-frequency variations in magnetic fields could drive telluric currents that shift pore fluid pressures. Plasma injections into the ionosphere might generate atmospheric waves that ripple downward, reshaping stress fields deep within the crust. Such targeting would not need surgical precision. Earth's faults are not isolated. They form tangled webs where stress released in one place can cascade across hundreds of kilometers. A technology capable of creating broad electromagnetic anomalies could influence seismic activity without striking a bullseye. The motivations for such a system raise unsettling questions. Perhaps the intent would be scientific, an effort to map planetary interiors, probe fault mechanics, or assess crustal stability as a prelude to colonization. Earthquake patterns reveal vital information: the architecture of the crust, the distribution of resources, the long-term rhythms of geological change. A civilization preparing to settle a world would need such knowledge. Yet the darker interpretation is harder to ignore. To manipulate earthquakes would be to wield a strategic weapon of unimaginable scale. Coastal cities could be shattered, infrastructure crippled, whole regions destabilized. The humanitarian toll defies calculation. The Indian Ocean tsunami of 2004 claimed nearly 250,000 lives. The Tohoku disaster of 2011 triggered nuclear meltdowns. To imagine such events as deliberate experiments is almost unbearable. And yet, the timing of seismic and astronomical events forces us to ask uncomfortable questions. Correlations between geomagnetic storms and earthquakes, precursor anomalies in groundwater, ionospheric activity, and electromagnetic fields, the convergence of extraordinary space weather during solar cycle 25. Could these be hints of systematic probing rather than natural coincidence? The challenge is teasing apart design from the chaotic complexity of nature. Plasma physics operating on heliospheric scales may yield signatures that mimic intention, while cometary interactions with solar wind may generate patterns that look like artificial control. The true test lies in identifying unmistakable hallmarks of intelligence, targeted stimulation of specific fault systems, timing synchronized with maximum stress loading, or electromagnetic signatures inconsistent with solar and geomagnetic variability. Thus far, seismic activity remains within expected natural ranges, even if its timing is curious. The Kamchatka Peninsula's violent sequence fits the story of tectonic loading, but October's perihelion passage of 3I Atlas could provide the clearest test yet. If this object is more than a comet, its closest encounter with the Sun may coincide with electromagnetic anomalies strong enough to influence seismic activity in ways that cannot be dismissed. Never before has global monitoring been so comprehensive. The seismic network now detects every quake above magnitude 4 within minutes, pinpointing timing, location, and rupture mechanics. Magnetometer arrays span continents, while satellites chart the heliosphere in exquisite detail. If directed energy effects exist, their signatures should emerge in the coming weeks. The implications are staggering. To confirm that major quakes can be triggered by alien technology would overturn not only seismology, but our assumptions about planetary security. It would suggest that advanced civilizations may treat inhabited planets as testbeds, conducting experiments that inflict disasters on unsuspecting populations. Their ethical codes, if they exist, may be as alien as their machines. A more generous interpretation is possible, that systematic probing represents a planetary survey, a gathering of data with no intent to harm. The quakes could be tragic side effects of research into crustal structures, much as laboratory tests sometimes produce collateral consequences. The truth is that we stand at the edge of ignorance. The electromagnetic interplay between vast cometary comas and the solar wind belongs to a realm of physics we are only beginning to understand. What we can do is observe, with instruments finer than any humanity has wielded before. In the weeks ahead, as 3I Atlas sweeps past the Sun, we will gather data that may reshape our grasp of how the solar system functions as an interconnected electromagnetic whole. Whether the evidence affirms natural causes or hints at the deliberate hand of intelligence, it will enlarge our knowledge of processes that dwarf anything we can reproduce on Earth. The universe is conducting experiments on a stage measured in millions of kilometers, and we are only just learning how to watch. The real question is not whether directed energy effects exist, but whether we are perceptive enough to recognize them if they do. As 3I Atlas draws nearer to the Sun, we are about to witness plasma physics on cosmic scales. If the patterns we see defy our assumptions, we may be forced to expand our understanding, and with it, our sense of what it means to share the galaxy. Part 10. The October Nexus and the Unknown Danger. October of 2025 is emerging as one of the most remarkable months in astronomical memory. A convergence of celestial events that reads less like a calendar and more like the pages of an apocalyptic chronicle. Yet unlike the visions of prophets, these alignments are real, calculable, and verifiable by the tools of science. The question is not whether they will occur, but what they will reveal about our planet and the deeper workings of the solar system itself. At the heart of this cosmic drama lies the new moon of October 21st. When Earth's satellite aligns directly between our world and the Sun, such events happen with metronomic regularity. But this particular new moon coincides with alignments that no living generation has witnessed. 9 days later, on October 30th, 3I Atlas sweeps into perihelion, reaching its closest pass to the Sun at roughly 1.4 astronomical units. That places it well outside Earth's orbit, farther than Mars at its near approach, yet close enough for its immense carbon dioxide, a rich coma, to collide with the turbulent solar wind now surging toward maximum strength in solar cycle 25, even before Atlas makes its fiery approach. Another comet enters the stage between October 19th and 21st. Comet C, 2025. R2 Swan draws within 0.26 astronomical units of Earth, about 1/4 the distance to the Sun. Its developing tail could stretch across several degrees of sky, visible through binoculars and possibly to the naked eye under pristine conditions. For scientists, this overlapping sequence has been dubbed a reset configuration. Multiple cosmic players arranged in ways unseen since before modern space weather monitoring began. It is as though the universe itself were setting up an experiment in heliophysics, a chance to test theories about how celestial mechanics might echo through terrestrial systems. What makes this convergence especially compelling is that we are not dealing solely with familiar comets. 3I Atlas carries the chemistry of another star system, a package of alien ices now unraveling under solar heat. Its coma, rich in carbon dioxide and exotic volatiles, represents conditions we have never before observed in the heliosphere. While direct optical viewing will be difficult, Atlas remains lost in the Sun's glare. During much of October space, telescopes continue to record its spectral and electromagnetic signatures in radio, infrared, and X-ray wavelengths. By contrast, Swan offers a show for Earthbound observers, its tail already stretching 2.5 degrees across the sky, 5 times the apparent width of the full moon. Meanwhile, the Sun itself is restless. In recent weeks, geomagnetic storms of G3 strength have rattled Earth's magnetosphere, while solar flares and coronal holes continue to stir the heliospheric plasma. These are the very conditions some researchers suspect may couple to seismic processes, producing the electromagnetic vacuums thought capable of nudging loaded faults. October's alignments create, in effect, a stress test for those ideas. Multiple comets, a Sun near peak activity, and an Earth still reverberating from July's massive Kamchatka rupture. The scientific community is watching with unusual intensity. Seismologists, though cautious, acknowledge that the overlapping variables form an unprecedented natural laboratory. If electromagnetic coupling between space weather and earthquakes exists, October could provide the clearest evidence yet. Others go further, suggesting the period may represent a symbolic reset, a turning of celestial gears that influences electromagnetic fields across the solar system. These interpretations blur the line between physics and pattern, but they remind us that human cultures have long read meaning into the sky. Indeed, the October 21st new moon occurs in Virgo by astronomical reckoning, though astrology would place it in Libra. Symbolism cannot shape magnetic fields, but the psychological weight of converging cosmic spectacles can ripple through societies. History shows that financial markets, political movements, even individual choices can shift during moments when the heavens appear unusually alive. The story does not end in October. Preliminary models suggest that Earth may cross debris streams shed by 3I Atlas in 2026. Should that occur, our planet would encounter meteors, not from our own solar family, but from an alien system. The chance to capture and analyze such particles in terrestrial laboratories would be revolutionary, providing direct samples of interstellar chemistry and the conditions of distant stellar nurseries. For now, however, no official space agency has identified Hasados's debris paths. The risks appear minimal. What lies ahead is not danger, but opportunity, the chance to witness and measure a cosmic convergence unlike any in recorded history. The trajectory of 3I Atlas keeps it comfortably distant from Earth's orbital track, and for all its grandeur, its dust production appears to follow the ordinary rhythms of cometary physics. What remains uncertain is not its path, but the electromagnetic theater that will unfold around it, the simultaneous interplay of solar wind, multiple cometary plasma envelopes, and Earth's own magnetospheric responses creates a problem in space physics as unsolvable as the classic three-body puzzle of celestial mechanics. Simulations can sketch possible outcomes, but the truth will only reveal itself through observation. The perihelion of October 30th marks the climax of Atlas's apparition as it rounds the Sun at closest approach. Its surface ices will vaporize at maximum intensity, driving the coma to a size that may eclipse even the Sun itself in sheer diameter. For astronomers, the spectroscopic window is unparalleled. Every major space-based telescope capable of peering near the solar glare will be trained on this visitor, gathering data on alien chemistry, plasma turbulence, and magnetic field structures never before witnessed. Ground-based radio arrays will capture electromagnetic emissions, while orbiting X-ray observatories record high-energy cascades in the ionized coma. The resulting trove of data will occupy plasma physicists for years as they untangle what nature is about to stage. From Earth's standpoint, the question is sharper. Will this spectacle in the heavens translate into measurable consequences below? The correlations between geomagnetic storms and earthquakes, the whispers of electromagnetic anomalies tied to space weather, all theories long debated at the margins of science, will face their defining trial during October's convergence. If such coupling is real, this will be the month it shows itself. If not, the absence of any correlation amid so much astronomical activity may finally lay the hypothesis to rest. Either way, clarity is coming. The true risk is not catastrophe, but revelation. that our models of how the solar system breathes with magnetic energy are incomplete, that we inhabit a cosmic environment whose currents and pulses we scarcely understand. The universe is about to perform an experiment in plasma physics and geophysics on scales we have never witnessed. Whether humanity is ready to comprehend the results remains an open question. But ready or not, October of 2025 promises to redraw our understanding of the electromagnetic world we live within and of our place in the greater cosmic community. The convergence is at hand, bringing with it answers to questions we have only just learned how to ask. Part 11. The Full Comet Swarm. In the final months of 2025, the inner solar system has become the stage for what astronomers are calling a comet swarm. 7 distinct visitors arriving almost simultaneously in one of the most crowded and scientifically rich periods of comet observation in living memory. At the center of this cosmic drama is 3I Atlas, the interstellar wanderer whose carbon dioxide-rich coma has swollen to nearly half the diameter of the Sun. On October 30th, it will reach perihelion at 1.4 astronomical units, passing Earth at 1.8 ADU, continuing to astonish scientists by remaining active at distances where most comets would still lie dormant. Sharing the spotlight is C, divided by 2025 R2 Swan, perhaps the most visually spectacular, which will sweep past Earth around October 19th to 21st at just 0.26 AU. Already, its tail spans 2.5 degrees of sky, 5 times the width of the full moon, and from dark locations it may become visible to the naked eye. A ghostly streak across autumn skies. Then comes C, divided by 2025 A6 Lemon, the wild card of the group, brightening far faster than forecasts suggested, and now on track to reach 4th magnitude by late October, a surprise transformation that has captured the attention of amateur astronomers worldwide. Earlier in the season, C, dividido por 2025 Cuno Atlas, offered a quieter prelude, reaching perihelion on October 8th and serving as a warm-up act for the spectacle that would follow. In early November, the periodic comet 210P Christiansen will return, a familiar traveler whose predictable orbit provides a point of comparison against these unpredictable newcomers, extending the performance into 2026. 24P Xiaomas will keep the show alive, allowing researchers to track how comets evolve under the stormy conditions of solar cycle 25. And in the background still lingers the memory of C, divided by 2024 G3 Atlas, a sungrazer that blazed earlier in the year, offering baseline measurements that now frame the present convergence. What makes this gathering extraordinary is not just the number of comets, but the way they reveal the mechanics of the solar system itself. Each comet grows 2 tails by entirely different processes. The dust tail, driven by the faint push of sunlight, bends into a graceful arc as particles of different sizes drift outward. The ion tail, born from the violent meeting of solar photons and neutral gases, erupts into a straight blue spear that always points away from the sun, tracing the invisible architecture of the solar wind, with 7 comets active at once, each sampling a slightly different electromagnetic environment. The solar system has become a vast, natural plasma laboratory. During storms, these tails can behave with startling drama. In 2007, spacecraft captured the moment a coronal mass ejection sheared away. Comet Encke's plasma tail entirely, as if the sun had snapped a whip through the comet's body. Now, with multiple comets plunging through a heliosphere already turbulent from Solar Cycle 25's peak, such phenomena may occur again, giving researchers the chance to study plasma physics across millions of kilometers of space. It is as though the cosmos itself has choreographed a grand experiment, placing these icy wanderers before us not as isolated curiosities, but as a living demonstration of how energy and matter flow through the vast electrical circuit we call the solar system. Solar Cycle 25 has reached its fever pitch, and with it comes a stage set for some of the most dramatic cometary phenomena ever observed. Under these stormy solar conditions, the chance of witnessing disconnection events, those sudden moments when a comet's plasma tail is severed by a coronal mass ejection, grows higher by the day. Now, with 7 active comets plunging toward perihelion in unison, the sky has become a living laboratory, each object revealing how its plasma environment responds to the turbulence of the solar wind. For amateur astronomers, the spectacle is nothing short of a gift. Comet Swan unfurls its luminous tail across binocular fields, changing subtly from one night to the next, while Lemon's rapid brightening makes it a moving target for photographers eager to capture its transformation. Even for those with modest equipment, these are nights when the cosmos itself appears alive and shifting. Professional astronomy is seizing the opportunity with equal fervor. Never before have so many diverse comets converged during a solar maximum. Some are periodic, others long period, and 13I Atlas has come from beyond the stars themselves. Comparing its carbon dioxide-rich chemistry and early outgassing to the more familiar behavior of solar system natives like Christensen provides a once-in-a-generation chance to probe the differences between interstellar wanderers and local comets. Across the globe and above it, observatories are coordinating like orchestras playing in harmony. The James Webb Space Telescope devotes precious hours to parsing the spectral fingerprints of each object, unlocking the secrets of their ices and dust. Hubble continues its meticulous imaging, catching the intricate structures of their comas and tails in detail that ground-based telescopes could never resolve. Radio arrays capture the faint murmur of plasma interactions, while X-ray observatories follow the high-energy violence where cometary gas collides with solar wind streams. Together, these instruments are weaving a multi-dimensional portrait of how these fragile wanderers both endure and surrender to the forces that dominate our star's domain. From the perspective of space weather, the swarm is nothing less than extraordinary. Each comet is a natural probe, a plasma bubble carried along by the solar wind, reacting in real time to the shifting currents of electromagnetic force scattered across millions of kilometers. They provide simultaneous measurements of magnetic field structures, particle densities, and turbulent plasma waves, data that no fleet of spacecraft could ever hope to gather. For plasma physicists, this is an unrepeatable experiment on a cosmic scale. The theories of heliospheric current systems, wave propagation, and electromagnetic coupling that once lived only in equations are now being tested by nature itself. Yet beyond the science lies something even more profound. The comet swarm reminds us that the solar system is no quiet clockwork of planets gliding through emptiness, but a restless, interconnected circuit where even fragile visitors from interstellar space can shape the electromagnetic weather that envelops Earth. 7 comets converging during the height of a solar maximum is no mere curiosity. It is the universe placing a mirror before us, showing the dynamism of the system we inhabit. As October shades into November, we will see multiple tales unfurling across the heavens, sudden disconnections tearing them away, and the restless interplay of plasma environments under the breath of the sun. For those who look up, this is more than spectacle. It is revelation. The comet swarm of 2025 is not only a feast for the eyes, but a window into the very processes that built planets, sculpted atmospheres, and may one day carry us between the stars. The cosmos has dimmed the lights and drawn back the curtain. The play has only begun, and we tiny observers on a fragile world have been given front-row seats to watch the drama unfold. Part 12. The Energy Tsunami. There is a storm unfolding around our planet, invisible to the eye yet more powerful than any hurricane or typhoon in recorded history. As solar cycle 25 surges toward its peak, the sun is releasing electromagnetic fury on a scale that occurs only once in 11 years, sometimes even less frequently. What we are witnessing is not merely heightened solar activity, but a profound restructuring of the electromagnetic shield that envelops and protects Earth. The data paints a picture that is both awe-inspiring and unsettling. Sunspot counts, steadily climbing through 2024 and 2025, have surpassed many expert predictions. Each day, the Solar Dynamics Observatory reveals our star's surface twisting with magnetic violence, a restless ocean of field lines that knot, snap, and explode outward. A single flare releases energy equal to billions of nuclear detonations. A cascade of charged particles and radiation racing across the solar system at nearly the speed of light, reshaping Earth's magnetosphere for days or weeks at a time. Yet it is not only the spectacular eruptions that define solar maximum. The very character of the sun alters during these periods. The solar wind grows erratic, switching unpredictably between high-speed streams pouring from coronal holes and denser, slower flows from magnetically active regions. The heliospheric current sheet, that vast spiral of electric current threading outward from the sun's equator, becomes warped into a complex labyrinth of turbulence, carving zones of instability throughout the inner solar system. This is the environment into which 3I, Atlas, and the comet swarm are plunging. Rather than gliding through the relatively placid conditions of solar minimum, these visitors find themselves navigating a heliosphere at the height of its electromagnetic chaos. What makes this moment historically unique is the perspective we now possess. Solar Cycle 25 is the first maximum to be observed with a full armada of instruments scattered across the solar system. Earlier generations could only rely on sunspot counts and magnetometers stationed on Earth's surface. Today, spacecraft provide real-time readings from nearly every vantage point. The Parker Solar Probe skims closer to the sun than any craft in history, directly sampling solar wind at its fiery source and revealing magnetic geometries that defy long-standing models. Solar Orbiter complements it with sweeping observations that map wind evolution in 3 dimensions as it spirals through space. The result is an unprecedented portrait of solar maximum. Magnetic field lines reconnecting in minutes, particles whipped to velocities exceeding 700 kilometers per second, waves of electromagnetic energy surging outward across astronomical distances, When this raw solar energy collides with Earth's magnetosphere, the consequences are both beautiful and disruptive. The auroras of 2025 have painted skies green and crimson as far south as the Carolinas. While GPS networks faltered, flights were rerouted away from polar routes, and utilities across North America reported worrying currents pulsing through their grids. The G4 storm of early 2025 demonstrated the fragility of modern infrastructure when confronted with space weather, forcing power operators and airlines alike into emergency responses. But what sets the current chapter apart from any solar maximum before is the convergence of unusual celestial visitors. Multiple comets, led by the interstellar giant 3I Atlas, have entered the stage at the same moment Earth's star is at its most volatile. H Comet's coma, an enormous sphere of plasma and dust, acts like a living probe, resonating with the solar wind and reshaping it in ways we barely comprehend. These are not passive objects, drifting silently through the void. They are vast electromagnetic structures that can bend magnetic fields, accelerate particles, and create bow shocks far beyond their luminous envelopes. Together, they form something like a cosmic orchestra, multiple resonant bodies vibrating in an already turbulent heliosphere, amplifying or distorting the storm in unpredictable ways. Traditionally, space weather has been seen as a one-directional force, with the sun dictating conditions for every other body within its reach. But the presence of cometary plasma regions on this scale suggests a more dynamic feedback system, where even small wanderers can exert influence on the larger electromagnetic theater. 3I Atlas, with its coma stretching hundreds of thousands of kilometers, stands out as a particularly disruptive presence. Its interactions rippling outward through the solar wind like boulders splashing into a rushing river. Multiply that disturbance by 7 active comets, all coursing through an environment already at maximum volatility, and the possibilities become staggering. Science is only beginning to grapple with these questions. We are standing at the edge of frontier physics, where the behavior of electromagnetic systems on cosmic scales remains largely uncharted. And yet, the significance of this moment extends beyond instruments and models. For millennia, humanity has looked to the sky and read meaning into celestial storms. Unusual activity overhead has always resonated with events on the ground, shaping cultures, shifting beliefs, and sparking change. As October 2025 approaches its crescendo, we find ourselves caught in that same ancient tension, watching the heavens with awe and wondering what the storm above might mean for the fragile world below. Correlation may not prove causation, but it gestures toward a truth that human cultures have intuited for millennia. The rhythms of the cosmos and the rhythms of human life are not entirely separate. Today, the convergence of solar maximum, a swarm of comets, and global social unrest creates an atmosphere that feels almost scripted, as though history itself is leaning into some grand celestial narrative. Whether this is meaningful synchronicity or simple coincidence depends on how one views the relationship between cosmic events and terrestrial affairs. From the standpoint of physics, solar activity unquestionably shapes Earth's electromagnetic environment in measurable ways. The global electric circuit, a system of currents linking the ionosphere to Earth's surface, pulses in response to fluctuations in space weather. Instruments around the world record these changes. Subtle, yet undeniable. Some researchers suggest these variations might ripple into biological systems, influencing everything from the behavior of bacteria to the functioning of the human nervous system. The idea remains speculative, but laboratory experiments confirm that living organisms can react to electromagnetic field changes at magnitudes comparable to those produced by geomagnetic storms. If true, the implications are profound. Periods of heightened solar activity, such as the present maximum, could reach into realms of human experience once thought to be beyond the grasp of physics, mood, cognition, collective behavior. The metaphor of an energy tsunami becomes especially apt when considering the scale of the forces involved. A severe geomagnetic storm contains electromagnetic energy surpassing the total electrical consumption of human civilization by orders of magnitude. This energy does not merely disperse harmlessly into space. It floods through every conductive system that surrounds and sustains us. Power grids strain under induced currents capable of damaging transformers and causing cascading blackouts. Pipelines suffer accelerated corrosion as telluric currents snake invisibly through buried steel. Even the human nervous system, a living lattice of electrical signals, exists within this stormy ocean of unseen forces. As October advances, the convergence of solar maximum and cometary activity heightens the expectation that these interactions will intensify. Solar activity lingers at elevated levels for months around the peak, while comets such as 3I, Atlas and Swan will be shedding maximum volumes of gas and dust, their vast comas and tails swelling into immense electromagnetic laboratories. Together, they form what might be described as a perfect storm of space weather. Multiple powerful sources of plasma and radiation overlapping within a heliosphere already electrified by solar cycle 25. The outcomes could range from dazzling auroras dancing across mid-latitude skies to the sobering reality of technological disruptions. Satellites, communication networks, navigation systems, and terrestrial grids all stand as test subjects in this stress test of planetary resilience. What we are living through is more than just an unusual astronomical season. It is a natural experiment on a cosmic scale, pressing every part of Earth's electromagnetic ecosystem and by extension the technological framework of modern civilization. The storm gathering now will not only challenge infrastructure, but also deepen our understanding of how vulnerable we are, how interconnected human systems are with solar forces far beyond our control. The energy tsunami is real, an ocean of invisible power sweeping past our world, a reminder that our place in the solar system is not insulated but immersed. Whether this moment is seen as ominous or as a gift depends on perspective. It could be framed as warning, exposing fragilities in the systems we depend on daily, or it could be embraced as opportunity, a chance to gather data that will shape our knowledge for decades. Either way, one fact is undeniable. Humanity is about to experience space weather conditions no previous generation has ever faced, and the record we collect will echo long after the storms themselves subside. The universe, however, seems unwilling to rest on spectacle alone. On September 10th, 2025, as if to punctuate the mounting tension, Earth offered its own reminder of instability. At precisely 11:27 in the morning, Mountain Daylight Time, Seismometers along Utah's Wasatch Fault Zone jolted to life, recording a magnitude 4.1 earthquake. The tremor that struck just southeast of Salt Lake City seemed unremarkable at first glance. A magnitude 4 event, originating 6 kilometers beneath the surface, entirely consistent with the restless behavior of the Wasatch Fault system. For Utah, this was business as usual. The region has endured such quakes for millennia, products of the ongoing stretch of the Basin and Range Province as North America continues its intricate tectonic dance. Local residents are accustomed to these tremors, which tend to arrive every few months, and seismologists classify them as minor disturbances rather than harbingers of catastrophe. What made this particular quake stand out was not its size or geology, but its timing. Less than 4 hours later, the same state became the stage for a different kind of shockwave. This one political rather than geological. An assassination attempt on a polarizing public figure jolted a nation already riven by division. Though the attacker was swiftly apprehended, the act carved yet another fracture into an already strained society, reinforcing a sense of instability that has been building steadily through the year. 2 events. One day, one state linked only by coincidence and geography. And yet, when examined against the backdrop of heightened space weather, the juxtaposition becomes harder to dismiss outright. September 10th fell within a period of elevated geomagnetic turbulence. Just days before, a G3 storm had swept across Earth's magnetosphere, leaving solar wind conditions unsettled, with high-speed streams pouring from coronal holes and stirring electromagnetic unrest across the planet's near-space environment. Against this background of cosmic volatility, the Utah quake and the attempted assassination appeared less like isolated episodes and more like notes in a larger, discordant symphony. From a purely statistical perspective, of course, no causation can be claimed. Earthquakes are routine here. Political violence, tragically, has become distressingly common across the United States. The overlap in time and place could be nothing more than the tyranny of probability at work. But human cognition thrives on pattern recognition. Our brains are wired to connect dots, even when the lines between them may be illusions. Researchers who probe the influence of space weather on biological and social systems argue that the matter may not be entirely one of perception. Some suggest that geomagnetic disturbances can subtly affect neural activity, altering mood, cognition, or behavior in ways that might make volatile individuals more prone to action. The same electromagnetic fluctuations, coursing through Earth's crust as telluric currents, could nudge stressed fault systems closer to rupture. Neither mechanism has gained broad acceptance, but both remain tantalizing possibilities. The key idea is not that space weather creates events from nothing, but that it might tip systems already on edge, whether a fault line under tectonic strain or a society seething with political polarization into sudden expression. The Utah events underscore the profound difficulty of disentangling real causation from coincidence. Each, viewed independently, was expected. The Wasatch Fault was always likely to release a tremor. The current political climate has primed the nation for eruptions of violence. Taken together and placed against the backdrop of geomagnetic unrest, they invite speculation about deeper connections. Whether or not such connections exist, one point is beyond dispute. Space weather does influence the systems upon which modern life depends. It disrupts satellites, scrambles communications, destabilizes power grids, and alters the electronic networks that mediate our political and social discourse. In that sense, the invisible storms above us already shape the world below, whether through direct electromagnetic effects on the Earth itself, or through the fragile systems of human society that depend so heavily on stable technological foundations. Geomagnetic storms ripple through modern civilization in ways both obvious and subtle. They can degrade GPS accuracy, scramble satellite communications, and induce currents in power grids that destabilize everything from financial markets to social media platforms. In quiet times, these disruptions might amount to little more than inconvenience. But during periods of crisis, their cascading effects can amplify instability. A trading algorithm misfires because its timing signal falters. Emergency communications collapse at the very moment they are most needed. Social networks seize up when public discourse is already stretched to breaking. The September window of solar turbulence brought precisely these conditions. While individual impacts on technology were modest, the cumulative weight of minor glitches created an electromagnetic undertone that could have sharpened tensions already running high. Patterns echo beyond Utah. Throughout 2025, clusters of unusual seismic activity have overlapped with surges of political unrest, and spikes in geomagnetic turbulence have coincided with outbreaks of protest and instability. The global demonstrations that flared during the September G3 storm are emblematic. Grievances had long been festering. Yet the sudden synchrony of protests across continents during days of geomagnetic agitation is striking enough to merit scientific scrutiny. Still, the deeper question looms: are these correlations real, or the product of our brain's relentless drive to weave meaning into coincidence? Periods of heightened astronomical drama, like the present moment of solar maximum and cometary convergence, prime us to notice connections. A quake and a political assassination in the same state. Auroras painting the skies while crowds fill the streets. These juxtapositions feel charged, even fated, but they may be nothing more than random overlap, magnified by human pattern recognition. As October approaches, with its extraordinary alignments and solar turbulence, more such synchronicities will almost certainly appear. The challenge is to hold steady between skepticism and imagination, recognizing coincidence without dismissing the possibility that the cosmos may, in subtle ways, be shaping the rhythms of our planet's geology and society. Part 13: Archetypal Shift. Death, rebirth and radical. When the heavens grow restless, something deep stirs in the human imagination. History shows us again and again that eras of unusual celestial drama tend to coincide with turning points in human consciousness. Moments when societies are forced to re-examine who they are and what their role might be within the greater cosmos. The convergence unfolding in late 2025 carries that same archetypal resonance. It bears the familiar signature of endings and beginnings, of old patterns dissolving and new ones struggling to be born, of a liminal space where the only compass available is radical responsibility. On October 21st, the new moon arrives with astronomical precision, calculated down to the second by orbital mechanics. Yet beyond its mathematical certainty, it carries symbolic weight that resonates far deeper. It comes at the exact moment when comets, planets, and our own star seem to weave themselves into a rare harmony. Like instruments in a cosmic symphony, science may insist this is mere coincidence. But for the human psyche, the timing feels almost intentional, as though some vast intelligence had scripted a ritual of renewal. This pattern of death and rebirth is etched into every level of reality we can observe. Seeds must rot in the soil before they can split open and sprout. Forests burn so that new ecosystems can emerge from the ash. Within our very bodies, cells die constantly so that life as a whole can continue. These cycles stretch from the microscopic to the galactic, suggesting that transformation is not an accident but a universal law. In the symbolic language of the stars, the constellation Virgo, where the October new moon appears by astronomical reckoning, has long been associated with harvest, purification, and preparation for renewal. The astronomical details may differ from astrological traditions, but the archetypal themes resonate with striking appropriateness for the moment humanity now inhabits. Because this is not simply about the sky, it is about the context in which these alignments unfold. Humanity finds itself in a crucible where environmental strain, technological upheaval, social fragmentation, and existential questions about our survival converge. It is precisely in such moments that radical responsibility becomes not an option, but a necessity. We cannot control the solar storms or the comets, nor can we predict with certainty how our societies will respond to these pressures. What we can control, what remains unconditionally ours, is our response. Radical responsibility means abandoning the seductive fiction that we are victims of circumstance. It requires the courage to recognize that how we interpret, how we choose, how we act in each moment, is the ground upon which our destiny is built. Such responsibility is not only external but internal. In times of division, human communities project their unacknowledged shadows outward, seeing their own fears and flaws reflected in their enemies. The demonization of political opponents, amplified by the algorithms of social media, is simply the collective acting out of what has not yet been integrated within. The convergence of the heavens offers us an opportunity, if we dare take it, to reclaim these disowned aspects of ourselves. Shadow work demands honesty, the willingness to see the selfishness, cruelty, and ignorance that reside within each of us. Only by naming these forces in ourselves can we stop unconsciously projecting them onto others while condemning their behavior. This is where fierce compassion enters. To practice it is not to excuse injustice, but to recognize the shared humanity that persists even in those who have strayed farthest from it. It is to hold boundaries firmly while refusing to allow hatred to calcify the heart. True forgiveness is perhaps the most radical responsibility of all. It is not denial, nor naive absolution, but the release of resentment that corrodes the soul. To forgive is to free oneself from the prison of anger. It is to accept our own imperfections as part of the human condition, not as excuses but as invitations to growth. Periods of cosmic intensity, such as the one we now enter, often accelerate the possibility of transformation, whether through subtle shifts in neural activity induced by the heightened electromagnetic environment, or through the sheer psychological impact of witnessing the heavens in upheaval. Human beings find themselves more open to new ways of seeing. The convergence does not force change upon us. It offers a mirror, What we do with that reflection, whether we retreat into fear and division or rise into responsibility and renewal, remains our choice. The symbolic weight of celestial alignments has always acted like a key turning in the lock of collective imagination, opening doorways into new ways of seeing and being. Yet those openings are not automatic passages. They are invitations, not guarantees. The currents of October do not carry us like passive leaves on a river. They present a choice, a moment to step forward with awareness and responsibility, or to retreat into familiar cycles that no longer serve. Transformation never arrives fully formed from the outside. It ripens through the convergence of cosmic conditions and human willingness. The sky may tremble with omens, but the work of growth is always grounded in what we choose to practice with our own hands, hearts, and minds. Practical steps become the bridge between symbolic promise and lived transformation. Meditation and contemplative stillness train us to observe thought and emotion without drowning in them. Writing in a journal draws unconscious assumptions into the light where they can be questioned. Walking under trees, watching moon phases, eating foods in rhythm with the seasons, these simple acts root us again in the larger patterns of which we are a part. They are not esoteric rituals, but reminders that human beings are woven into the same fabric as comets, tides, and solar winds. Community gives flesh to archetypal change. Without connection, insight risks dissolving into abstraction. Service, creative expression, and honest presence in relationships become the channels where inner awakening reshapes outer reality. Just as no star shines in isolation, individual transformation radiates most powerfully when it participates in the constellation of the whole. The death and rebirth cycle now unfolding presses us to release identities and stories that no longer allow us to grow, careers that define us too narrowly, relationships that trap us in unconscious loops, beliefs that shrink our sense of possibility. All of these must be offered to the fire if something new is to be born. The October 21st new moon and the October 30th perihelion of Three-Eye Atlas embody this invitation with uncanny clarity. Old modes of humanity, reactive, divided, resigned to victimhood, are showing their limits in the crises that surround us. The cosmic convergence does not demand but does encourage. Choose awareness, choose responsibility, choose evolution. The truth is that we do not yet know whether celestial events exert measurable effects on consciousness. The deeper question is whether we will respond to whatever influences exist with wisdom or with fear. The heavens may be indifferent, but the meaning we draw from them and the courage we muster in their light can shape the destiny of life on Earth. The universe offers its signs. It is we who must decide whether to heed them, and whether we will rise to the responsibility of becoming more conscious participants in the unfolding story of our world. Part 14. Conclusion. Here we are, on the cusp of November 2025, looking back across a month that has unfolded like a cosmic epic. The heavens have not been quiet. The sun, once subdued, has risen into full voice, its magnetic tempests surging with a ferocity that exceeded the cautious expectations of forecasters. Solar Cycle 25 has carved auroral fire into skies far beyond the poles, while its geomagnetic storms have bent the architecture of our technological world, shaking satellites and disrupting the silent synchrony of GPS signals that underpin global life. Above, The cometary chorus has swelled. 7 celestial wanderers swept through the inner solar system in a rare convergence, each leaving its spectral signature. Among them, one stood apart, 3I Atlas, the third confirmed interstellar visitor, dragging behind it a coma so vast it rivaled half the diameter of the Sun. It came not as myth, but as measurable reality, documented through the lenses of Hubble, the spectrometers of Webb, and the vigilant eyes of astronomers across the globe. The skies themselves became a manuscript, etched with dust and plasma tails, luminous brushstrokes across the canvas of deep space. Meanwhile, Earth's crust answered in kind. Kamchatka convulsed with a magnitude 8.8 rupture that reordered its fault lines and shortened the length of our day. Utah's Wasatch system trembled with smaller but symbolically charged echoes. Networks of seismographs traced every pulse, their graphs recording the invisible heartbeat of a restless planet. These events were indisputable in their occurrence, as undeniable as the cosmic phenomena that framed them, yet whether their proximity in time reveals an underlying unity or mere coincidence remains unsettled. Caught in the gulf between curiosity and certainty, this is the frontier where science and story converge. On one side stands empirical rigor, which refuses to accept temporal proximity as proof of causation. It demands mechanism, reproducibility, statistics that rise above chance. On the other side, human consciousness wired through millennia to search for patterns in the stars, and the soil cannot help but wonder whether threads run deeper than our equations can yet reveal. It is here that October's drama leaves its most lasting mark, not in confirmed discoveries, but in the mirror it holds up to our own minds. Periods of cosmic intensity ignite the architecture of human perception. They amplify our natural instinct to seek meaning, to weave scattered data points into coherent narratives. This instinct has always been both survival tool and myth-making engine. For our ancestors, vigilance to the rhythms of the heavens meant harvests timed correctly, migrations begun safely, storms anticipated. For us, it may mean passing terabytes of seismic data, solar indices, and geopolitical events. The difference is scale, not substance. When the sky flares with auroras, when the ground shakes, when comets bloom like ghostly blossoms across the void, our awareness sharpens, and we strain to hear what the universe might be saying. But this sharpened perception carries a dual edge. Surrounded by streams of global data, our brains wrestle with the sheer density of simultaneous events. Synchronicities multiply, connections appear everywhere, and the danger of mistaking coincidence for causation grows ever greater. At the same time, the opportunity has never been richer. For the first time in history, humanity can observe in real time the interplay of solar storms, cometary behavior, seismic processes, and social upheaval. We stand inside a planetary-scale experiment, with instruments sensitive enough to catch the faintest tremors of correlation across domains once thought entirely separate. Perhaps this is the true manifestation of October's cosmic drama, not proof that comets stir earthquakes or that solar winds shape human conflict, but revelation of how consciousness itself transforms under celestial pressure. The universe has set the stage with plasma and stone, light and shadow, we, in turn, respond by seeking patterns, building meaning, and asking questions we once lacked the courage to voice. In this way, the cosmic theater becomes not only a spectacle of astrophysics and geophysics, but also a crucible for human awareness, pushing us to expand our capacity to perceive, to imagine, and to evolve. As November unfolds, we carry forward not only the data points of solar winds, cometary comas, and seismic ruptures, but also the deeper recognition that cosmic events shape more than just the physical environment they shape us. The question of whether causal links exist between electromagnetic storms, interstellar visitors, and tectonic release remains open, suspended in the careful balance of scientific skepticism and human wonder. Yet what has become unmistakable is the way these events stir our imagination, quicken our pattern-making minds, and open new doors of creativity. History has shown us that the great astronomical dramas, the auroras that set northern skies ablaze, the comets that haunted medieval nights, the eclipses that turned day to shadow, often coincide with moments of cultural transformation. It is not necessary to prove that solar flares fire synapses, or that geomagnetic storms rewrite neural circuitry. It may be enough that cosmic spectacle gives us permission to think differently, to stretch the boundaries of what we consider possible. In that sense, 3I Atlas and its companion swarm are not only astronomical events, but psychological catalysts, igniting human creativity as surely as the sun ignites their streaming tails. But inspiration without discernment can lead us into confusion. The torrent of information available to us, the instant alerts from NOAA's space weather dashboards, the real-time seismic feeds from the USGS, the endless cascade of comet updates from observatories creates fertile ground for both genuine insight and elaborate illusion. Developing what might be called cosmic perspective becomes essential. The ability to situate ourselves within cycles vast and small, to recognize patterns without being consumed by them, and to remain grounded while gazing skyward. This perspective reminds us that the 11-year solar cycle is but one rhythm in a symphony of time that includes lunar months, seasonal oscillations, planetary orbits, and galactic revolutions. To glimpse even fragments of this music is to be humbled and empowered in equal measure. Here lies the practical core of manifestation during cosmic intensity. It is not the indulgence of wishful fantasy, but the disciplined directing of awareness and intention when conditions seem to amplify the currents of mind and matter alike. During periods of heightened space weather, negative emotions can flare into destructive spirals, just as easily as creative insights can surge into breakthroughs. To navigate this requires radical attentiveness. To track our inner weather with the same vigilance we track the KP index or seismic alerts. What we think and feel becomes magnified, reflected in the mirror of cosmic amplification. Thus, the true challenge and opportunity of late 2025 is not merely to observe the comets, auroras, and quakes, but to participate consciously in the resonance they awaken within us. To take the heightened pattern recognition that surges during these times and use it not to weave conspiracies of fear, but to forge new pathways of art, science, and community. To meet the archetypal death and rebirth energies not with resignation, but with radical responsibility for how we carry them into our choices, relationships, and creations. As the comet swarm disperses, as solar cycle 25 begins its slow decline, the lessons endure. The universe has reminded us that we are participants, not spectators. In its grand experiment of energy and consciousness, we cannot control the flares of the sun or the tremors of the earth, but we can choose how to respond, what meanings to draw, and how to shape those meanings into acts of creation. The cosmos has staged a convergence unlike any in living memory. What remains is how we carry its resonance forward. When the sky changes, we change. The cosmic journey continues, and with it, the invitation to evolve not just in knowledge, but in consciousness. The comets pass, the sun storms, the earth trembles, and humanity listens, learns, and manifests anew.